Good morning, everyone. Greetings from Vidyavadaka College of Engineering. I'm Madhushri, Assistant Professor, Department of Civil Engineering, signing in as Master of Ceremony for today's webinar, Case Studies on Geotechnical Investigations by Dr. C.R. Parthasarathy, Founder, Chairman, and Managing Director, Sarathy Geotech and Engineering Services Private Limited, Bengaluru, organized in connection with 119th birthday celebration of author Casagrande. I now request Dr. S.K. Prasad, Professor and Head of the Department, to welcome all to the session. Over to you, sir.
Good morning, everybody. I'm really extremely happy that, over the last 60, 70 days, we have probably organized 19 or 20 webinars in our institution, all because of the dynamic efforts by my young, colleagues here. So this one is in the area of geotechnical engineering, in which, I have my very good friend, Dr. Parthasarathy, making the presentation. Well, I have two important duties to perform. One, of course, to welcome everybody to this webinar. Secondly, to talk a little about my institution and my department. Well, firstly, let me welcome my very good friend, Dr. Parthasarathy, with whom I am associated for maybe 15 years plus. And over the last 3-4 years, we have become extremely close. And he has been involved with a series of webinars over during this pandemic period, which I really appreciate and respect. So, I have liked many of the good practices of Dr. Parthasarathy. Two very important ones I always want to mention are, one, he is one who takes up challenges. So if you talk to him, you will realize the importance he gives for taking up big challenges, taking international projects and so on. The second one, he wants to give out whatever he knows. And I was just asking him how many webinars you have given during the last pandemic period. He doesn't remember, but he says that, at least one in a week. So I heartily welcome you, Dr. Parthasarathy, for this webinar. And I would like you to be associated with our institution continuously. So, my welcome to Parthasarathy. And then, of course, all the participants. We are extremely happy that, participants have been very kind to us and have valued our organizations, activities which we perform. So I welcome all the participants. I'm sure there are academicians, there are students, there are professionals, there are researchers. Welcome to all of you, and please be part of all the webinars which we organize in future also. I then have to welcome all my colleagues, especially from the Department of Civil Engineering, both teaching and non-teaching, and young dynamic team. So my welcome to each and every one of you. The second aspect I just would like to spend is on my institution. Vidyavardhaka College of Engineering, situated in the center of city of Mysore, is one of the most popular engineering colleges in the state of Karnataka. It is popular because of the values it attaches. We have 6 undergraduate programs, 3 post-graduation programs, plus an MBA program. This is an autonomous institution under VTU from this year. We have NAC accreditation with A grade. All our departments have been NBA accredited. Very happy to mention that the Department of Civil Engineering is also very recently accredited with NBA with a very good score of 678 marks, which we received only a few days back. We'll be starting a new undergraduate program from this year, computer science in artificial intelligence and machine learning. The 6 undergraduate programs which we have, including civil engineering at present, are computer science, information science, electronics, electrical, and then mechanical engineering. With respect to my department, I feel very proud and happy that we are 16 of us among the faculty members. We have 60 intake. Our student teacher ratio is very healthy, 15:1 or better than that. We are in fact having one more person being appointed, and all our laboratories are very well furnished, and we have an average age group of about 35 plus. So we have an excellent seminar hall. We have a computer center with about 80 computers, so well furnished. I invite everyone to be part of our institution, come anytime. So without wasting much time, I'll hand over the mic to my good friend Madhushri for continuing her MC. Thank you, everybody.
Thank you, sir. I also extend a warm welcome to you, sir. I now request Professor Chetan to acknowledge the achievements of Arthur Casagrande. Over to you, sir.
Thank you, ma'am. Good morning, everyone. Today I'm here to represent a few words about Arthur Casagrande. So let me begin. Arthur Casagrande, he was born in 1902, on 1902 August 28 to September 6, 1981. He was an Australian-born American civil engineer who made important contribution to the field of engineering geology and geotechnical engineering during its infancy. He probably renowned for his igneous designs of soil testing operators and fundamental research on seepage and soil liquefaction. He is also credited for developing the soil mechanics teaching program at Harvard University during the early 1930s that has since been modeled in many universities around the world. And he developed so many operators, which includes the liquid limit operators, the hydrometer test operators, the horizontal capillarity test, odometer operators, and the shear box test, all of which still form the prototype for the ones in use of today. He was also a pioneer in the US for conducting the triaxial test, and he was the first person to study about the volume changes occurs of soil during the shear. And Casagrande served as a president of the International Society of Soil Mechanics and Foundation Engineering from 1961 to 1965. He was the first recipient of the Carl Turgigi Award presented by ASCE, that is American Society of Civil Engineers. He has won so many awards throughout his career, including being named the first ever ranking lecturer by the British Geotechnical Association, as well as a Turgigi lecturer by American Society of Civil Engineers. A number of awards have been established in his honor, including the Arthur Casagrande, the Professional Development Award. So thank you, ma'am. Thank you for explaining about Casagrande.
Thank you, sir. It is such a great day and great time to remember such eminent personality on his birthday. I now request Dr. Umesh, sir, to introduce today's speaker to the audience. Over to you, sir.
Thank you, madam. Good morning, one and all. It gives me immense pleasure to introduce today's eminent speaker, Dr. C.R. Parthasarathy. Dr. C.R. Parthasarathy is a founder, chairman, and managing director of Sarathy Geotech and Engineering Private Limited. He holds his BE degree in civil engineering and ME degree in Geotechnical Engineering from University of Bangalore. And he holds a PhD degree in Geotechnical from Indian Institute of Science, Bangalore, India during 2002. He has started his career as a geotechnical engineer in 1993. He was involved in numerous large-scale site investigation studies at various levels for multi-story complexes, industrial buildings, embankments, bridges, water retaining structures, subway, payments, offshore platforms, pipelines, mobile drilling units, etc. Dr. Parthasarthi has undertaken pile drivability studies, Jacob rig foundation investigation, and design including Jacob rig moves. He was involved in the pile installation, monitoring of several offshore platforms, and he has served as quality QA and PC engineer for several geotechnical investigation on dedicated survey vessels. His spheres of activities has extended beyond from India to Southeast Asia, Middle East, Africa, and USA. Dr. Parthasarthi is the founder director of Sarthi Geotechnic and Engineering Service Private Limited. The company, with its registered office at Bangalore, India, was established during 2008 to provide both offshore and onshore in integrated geotechnical engineering services in India and abroad. As a technical partner of Pile Dynamic USA, he is instrumental in promoting quality testing and FOF deep foundation in India and authorized trainer for high strain dynamic pile testing. He is a fellow of Indian Geotechnical Society and a member of several other professional bodies like DFI, ISRM, Indian Concrete Institute, Institution of Engineers, etc. He is currently elected National Elective Member of Indian Geotechnical Society, that is IGS, for 2018 to 2020, and Chairman, Indian Geotechnical Society, Bangalore Chapter. This is a brief introduction of Dr. Parthasarthi. Thank you, sir, for being with us. I once again welcome you, sir. Over to Madhusri, madam. Thank you.
Thank you, sir. Before moving on with the session, there are a few important announcements. Participants, for your kind attention, please. You can watch the video and submit your feedback form at the end of the session, and the feedback link will be active till 5 p.m. today. The feedback link will be put up in the YouTube chat box only. I repeat, participants, the feedback link will be put up in the YouTube chat box only. And any queries from the participants end, you can post in the YouTube chat box and will be answered by the speaker at the end of the session. You can post any queries in the YouTube chat box and will be answered at the end of the session. If any further queries, you can send it through the registered email ID and we'll get back to you with your answers. Thank you very much. We are now very eager to listen to the session by Dr. Sarthi, sir. Over to you, sir.
Yeah, thank you. Good morning to all of you. At the outset, I thank Vidyavardhaka College of Engineering for giving me an opportunity to share some experience. Thank you, Professor Prasad, for a warm welcome, and Professor Umesh for a very elaborate introduction, and of course, Madhusri, who is emceeing this entire program. So before I begin my presentation, I pray Almighty for giving strength and immunity to all of us amid this COVID pandemic. I wish all of you to stay safe and stay healthy. So what a day today. I am deeply humbled for this opportunity arranged by Vidyavardhaka College of Engineering on the occasion of celebrating birthday of Professor Casagrande. So I take this again opportunity to present few slides as a mark of tribute to Casagrande before I go into the presentation. As we all know, he is the master and stalwart of geotechnical engineering. On the left side, you could see the soil mechanics laboratory installed by Professor Casagrande along with the father of soil mechanics, called Tezagi. And the Casagrande bowl, the 1942 model invented by Professor Casagrande, I think is still in use among all of us. I just have to make one small submission here that the hardness of the base, the ASTM standards and the Indian standards, they're slightly different. The ASTM standards is pretty harder than what we normally use in the local geotechnical engineering. So, and we all know this plasticity chart, and this A line is perhaps due to Casagrande. So it is his contribution while arriving at the extremities on the consistencies parameters of soils. See some pictures, nostalgic pictures. He was in a meeting at Stockton, California, and with his students at the center red circle in 1942. In fact, he was a secretary of the first international conference on soil mechanics and foundation engineering, where Tezagi was the president of the conference in 1936. I read this in the literatures that it was a very, very successful conference. And you see a visit by Casagrande to the Panama Canal in 1969, and later almost a decade from there in 1978 could see him. So unfortunately in 1981 we lost him. He's a master, and we have a great tribute to Professor Casagrande. I once again thank for facilitating this webinar on the occasion of his birthday celebration. So before I begin the presentation, I want to give a very brief introduction of my company, just a couple of minutes. We have introduced some new products, so I just wanted to share that, and then I'll go to the presentation. So we started in late 2007 to provide integrated approach of services for both the offshore and online projects. And our vision is to be a leading player and service provider of choice in the fields of geotechnics and geophysics for both onshore and offshore markets. As an innovative geotechnical company complemented by geological and geophysical services driven by values, we provide top-class solutions with value addition to customers that are backed by best practices. So we bring in several decades of experience, collective experience of the entire team members, and also we have large depository of database spanning multiple geographies. It's not only the geotechnical data, but also the observational data on the foundation performance, because we also get involved in the pile installation and testing on multiple projects, and that gives us a big USP to bring in the value engineering. And we are globally present physically in Indonesia, Saudi, Vietnam, and UAE. In fact, the sectors that we operate is oil and gas primarily, but we also now expanded our domestic presence to real estate, railway infrastructure, mining, renewable energy, some small parts from the dam section. And nearly more than 50% of our revenue is consumed, service is consumed outside the country, and thus the revenue coming from overseas projects, and thus the state government and central government have recognized us in conferring the export award consistently for several years, and I'm confident that we will be honored with this award even this year too. The scope of service, geotechnical and geophysical investigation for the offshore constructions. Pile drivability study, this is a pre-installation study for selection of hammers, fatigue during driving, pile monitoring using pile driving analyzer. CAPAP is a post-test analysis, leg penetration analysis, and punch through assessment. I'll give a very brief introduction during the course of presentations on the Jacob foundations. The load transfer curves, mud mat analysis, all of them goes as a part of the engineering report when you perform the offshore geotechnical investigations. So we have several international softwares. The recent addition is Plaxis 3D for modeling three-dimensional soil structure interaction problems. The online space, geophysical investigations, we added all this the last few months. MASW seismic refraction resistivity test, geological investigations when you encounter rocks, geotechnical investigations with SPT analyzers. So I will touch upon this and give you some illustration on the energy measurements as we have accumulated some database for the last few months. Design of shallow and deep foundation, bearing capacity and settlements, stability of slopes, dynamic pile load test. This is the same pile driving analyzer to test the board piles, and pile integrity tester. Cross-hole sonic logging is again other integrity methods of verifying the shaft integrity. So all the green ones are NABL accredited, the PDA, PIT, and the cross-hole. And we have the shape and squid. I'll explain in the next slide. Our geotechnical laboratory is also NABL accredited, engineering investigations and designs. And finally, forensic geotechnics have got involved in few failure case studies. We are also experienced in providing an end-to-end solution for deep excavations. We have designed and built the temporary support system for deep excavations of about 18 meters vertical cut in Bangalore. As far as the deep foundation testing, static load test, axial compression, pull-out and lateral. The pile integrity test, this is NABL accredited. You see the accelerometers with a small handheld hammer, give you a low strain, stress waves propagates to the pile, and then the reflections, you can analyze the data and evaluate the pile integrity. Cross-hole sonic logging methods. This is another integrity methods where you need to embed these access tubes along the cage before pouring the concrete. So once the concrete is done on the pile, then you insert these trans receivers and then measure the pulse velocity with a known distance, and thus you can know the integrity of the pile. And you can also run some tomography. We have some additional softwares for that. And this is a shape on the right side. This is very useful for large diameter board piles where you have the ultrasonic sensors that is embedded around the periphery, which radiates, and you will know the diameter of the boreholes prior to concretings along the length, and to see whether it is vertical, inclined, or there is any lateral shift. And the bottom is the shaft quantitative identification device on this right side bottom one, which has 3 penetrometers and the retractable plates. Both the shape and the squid can be directly connected to the Kelly bar of the piling rigs. It can be lowered down. And this squid, when you lower down into the bottom of the borehole, it measures accurately what will be the depth of contaminations, particularly useful in end-bearing piles where most of the capacity is derived from the bottom. So we don't want that contamination to be there. Otherwise, it will fail the load test. And the high strength dynamic load test, this is a pile driving analyzer, the latest version, the 8th generation model. In fact, we are technical partners of Pile Dynamics to provide consulting, training, and conducting workshops in this part of the world. And the training includes the wave mechanics and background, how to do the test right is a proper practice, PDA data quality assessment, application, and interpretation. So this is a sophisticated gold standard signal matching technique, is a post-test analysis to evaluate the capacity of the pile and also the distribution of the capacities along the skin and the base, FF theory, operations, and examples. And this is a 3-day course. We can squeeze it to 2 days. Is a paid training. So if anybody is interested, so you can get back to us. We can customize the training on mutual convenient dates, and the contact details are here, and we can take it up forward. So with this brief introduction about the company services, so I will get into the presentation. Today I have structured it into 2 parts. I will talk about the offshore geotechnical investigations with few illustrations, and the second part I will talk about the onshore geotechnical investigations and also with a few illustrations. Essentially, I'll be talking on the cone penetration test, which is very widely used in the offshore geotechnical investigation. And in the on-land space, the standard penetration test, the energy measurements, and some case studies, we have accumulated the data for the last few months. And I'll be talking about the rock cores and the evaluation of the rock mass rating and how you can actually optimize your designs by looking into the core samples. So they're very simple and basic things, but I felt that is very important, so I thought I should share with all of you. At the first, why we need to carry out the geotechnical investigation? regardless of any of those structures that is built either in the land or in the ocean. It can be small buildings like your pavements. We see distress to those structures. And this pavement, what you see here, is due to the hill slope failures, and there are many other reasons for the failure of these pavements. Even the small residential buildings where hard-earned money is put for building a house for living will undergo distress because of not characterizing the ground properly and designing the foundations appropriately. Leaning Tower of Pisa, we know this because of the differential settlements, the tower is tilted, and thus this becomes a monumental wonder of the world. Map the sinkholes. So we never know the cavities and sinkholes. So we have some experience in Middle East in cavity mapping. That is very, very important, and without which it will be detrimental for the safety of several foundations. Right? I want to play one video here. The recent collapse of a 3-story building adjacent to a deep excavation. Probably, I think the soil was not characterized, and thus the design of those support systems was not proper, which ultimately gave way and resulted in the failure of that 3-story building. I'm sure this video is roaming around in the WhatsApp in many of you. I thought I should just share this. It's very important. So what I understand, the retaining wall is from a diaphragm wall. So generally, the concepts are different in the temporary retention system. It's so unfortunate. So we will get back to these problems. Perhaps Indian Concrete Institute and other association was talking that they want to organize some discussion on this in form of the webinars to find out what are the causes and what are the measures that need to be taken in order to prevent in the future. Maybe if I'm invited, I will be very happy to participate in that as well. Tall towers, even though it is built on piles, failures are imminent if it is not taken care on the ground characterizations and thus the designs. And so offshore structures is no exception. So we see many failures and distress for the offshore foundations. The one you see on your screen is the Jacob Rig foundation failure. There will be 250 people, 200 people will be on board. We can't afford to have this kind of failures. So thus it is necessary and important to characterize the ground and arrive at the ground model and use those ground model for the design of foundations. So let me give you some brief background on the offshore site investigations. We always advocate an integrated approach of site survey. So what is this integrated approach? Perform a geophysical investigation, identify the geohazards, and develop the scope of geotechnical investigations and use all the data together for assessment of the foundations and the designs. I'm not going to talk about the geophysical because of the paucity of time. So I'll give some brief introduction on the oil and gas projects and the structures. As you see on the left top screen, see this is a jackup rig with a ship by itself which has 3 legs. It will be towed by the tugboats. On a location, the legs will be lowered down into the seabed. As it touches the seabed, the ship will be lifted, slowly lifted out of water, and thus all the loads will be transferred on the legs. And thus the legs will start penetrating below the seabed, and it stops where your ultimate bearing capacity exceeds your applied load. Right? So then the cantilever will come out, and then they will start for exploration. So this is the exploration stage. So when they find that there is abundance reservoir, the quality of oil or gas is good, then they're going to, for the production stage, by installing a fixed platforms, as you can see here. Okay, these fixed platforms are jacket structures. The one you see on the screen is a 4-legged jacket structure. The height of this will be equal to the water depth, and this will be appended, placed on the seabed, and the piles will be driven through these cans and below the seabed until the desired penetration. Okay. When this jacket structure are lifted and appended, even before the piling is carried on, it has to withstand its self-weight. So this is by means of the temporary seafloor support. We call it as mud mat, as you can see here. It's a rectangular mud mat. It can be of any shape, square, rectangular, circular. It can be steel, it can be wood. And once the mud mats are designed so it can withstand the self-weight, it is appended on the seabed, then the piles will be driven through the cans until the target penetration is achieved. And finally, the entire jacket will be welded to the pile. So even the weight of the jacket will be transferred to the pile. So once the foundation is completed, this top deck is fabricated in the yard that will be put on the top of the jacket and they weld it. Now it's ready for the production. And right side you see is a fixed platform. Now you need some drilling rig. Either you can place the drilling rig on top of the jacket itself, but then the size of those structures and the piles will be very huge because to accommodate those drilling loads. But normal practice also is to bring this jack-up rig for the second time after the installation of the platform adjacent to the platforms, and then the cantilever will go on top of the platforms, and then they'll start for drilling that through some conductors. Those are the guides for the exploration wells. That will also be installed. It's a small size than the piles itself. Now, the site investigation is important, as we saw in the last couple of slides, to make an assessment on the foundations for the mud mats, foundations for the jack-up rigs, and design of pile foundations, and the many other things which I'm not going to talk today. So the knowledge of soils and rock is essential if the structures are to be built safely and economically, and the site investigation always raises a question. What is sufficient? So how many boreholes is necessary? What are the tests to be performed? So it should be sufficient enough to give a three-dimensional picture of the ground, both laterally as well as vertically. You could see a very nice geophysical data which has captured the vertical stratifications and also the lateral continuity of these stratifications across the locations. We could have one boreholes at these corners, one at the centers. The stratifications derived by the boreholes can be correlated with the geophysical methods. We call it as ground truthing. And once you're confident on the lateral continuity, perhaps you can develop your ground model and then use that for the design of foundations. So what is common in offshore geotechnical investigation in the methods? And then performing in situ test. The most common in situ test performed in the offshore site investigation is the cone penetration test. I will be talking about this cone penetration test, and I'll not talk about the other methods because of the paucity of time. Let me give a history of the CPT test. It was first developed in 1930s as a mechanical cone. Then the electric cones was developed in 1960s. Device for offshore geotechnical investigations were developed in the 70s, and advancement thereafter resulted in the pore pressure measurements, more reliable load cells, addition of seismic for shear wave velocity. This is still not very popular, although there are some projects utilize this. Additional sensor for environmental applications and significant increase in the documented case study. So that's a very valuable information, and also brings in confidence to use the CPT data for correlating and deriving the engineering parameters. CPT test and its enhanced versions such as the piezo cone and seismic cones have extensive applications in wide range of soils. Although the CPT is limited primarily to softer soils, with the modern large pushing equipment and more robust cones, the CPT can be performed in stiff to very stiff soils and in some cases soft rocks. So the size of the cone can vary. The most commonly used dimension is about 10 centimeters square, although you can have a smaller cones for very dense formation or a larger cones for very weak formation. There are some practice also to use the ball penetrometer and a T-bar penetrometer. Is very useful to characterize the upper half a meter to a meter of the soils for pipeline in very, very soft clays that we normally encounter in the deep water offshore projects. The procedures will be similar, only the correlation coefficients will vary because this is a cone, this is a ball penetrometer with a wider surface area, and this is another T-bar penetrometer with a different surface area. So I'll not talk about the ball and the T-bar, so let us focus on the CPT. The advantage of the CPT is it is fast, continuous profiling, repeatable and reliable data can be obtained. It is not operator dependent. So I mean the operator is independent means I give an example of measuring shear strength. So if you have a tar vein, for example, you need to apply a uniform vertical pressure and rotate or provide shear the soil. So while doing so, if the operator is not careful, the simple test, instead of shearing the soil, there will be a slip in the vein blade. So the slip will give you a very conservative value or lower predict the shear strength. But if the soil shears with a uniform vertical pressures, then you get an accurate assessment of the under shear strength. It's very simple, but it's very important. And CPT is not like that, so you don't have any operator dependency. This is economical and productive. It has a strong theoretical basis for interpretation, and also very wide correlation studies have been made. And the disadvantage is high capital investments. You need skilled operators. So there's some difference between the advantages and required skilled operators. The skilled operators are necessary to operate the equipment, to maintain the equipment. But the test as such, as per se, is not dependent on the person. So no soil samples can be obtained during a CPT test, and the penetrations can be restricted in gravel or cemented layers. The disadvantages supersedes, the advantages supersedes the disadvantages, and thus this has been very widely used in the offshore practice. The apparatus consists of the thrust machine, reaction equipment, push rods, piezo cone penetrometer, CPT or PCPT, and a measuring system. So let us examine this. This is a cone and a cone rod. This will be pushed by some thrust force. Here what you see normally in the offshore is the wheel drives, which can be electrically operated, which pushes the cone down. Okay, and then the data cable running all along to the data acquisition system. The measure ants, let me talk about the measure ants little, maybe next slide. Okay, the basic cone parameters. Normally the cone apex angle is 60 degrees. Okay, and the diameter is 10 centimeters square. This is the tip diameter. The sleeve friction is 150 centimeters square. And the pore pressure U2 is commonly measured behind the tip. But although there are other locations, U1 and U3, which is very uncommon, not so common, but most widely measured pore pressure locations is this U2 behind the tip. Okay. Though the important piezo cone measurements, that is the quantity that you intend to measure, is the cone resistance, sleeve friction, pore pressure. There is an inclination by use of inclinometers to ensure that you don't damage the cones, the penetration depth as you push the cone into the ground, the rate of penetrations. Normally, the cones are pushed at about 20 millimeter per second, the frequency of the later logging. So let us see how to measure the cone resistance. So what you see in the screen is your cone resistance versus depth, and this cone resistance is measured by the force divided by the area of the cone, right? And the sleeve friction is measured by the force at the sleeve divided by the area of the cone. On the right side, you see the black one is your pore pressure U2, the red one is your hydrostatic pressure U0, and U2 minus U0 is your delta U is the excess pore pressure. So these are the measured quantities in the CPT. So you have a cone resistance, sleeve friction, and a pore pressure. Right? You can see the data in real time as the data cable from the cone is attached to the data acquisition system. As you push the cone, you could see the data in real time. The blue one is your cone resistance, the red one is your sleeve friction, and the yellow one, pore pressure. The cone resistance, sleeve friction, then your pore pressures on the right side column. You need to calibrate the units. periodically to ensure that it is functional before you do the test is a site calibration unit. You can apply the pressure and measure the pressure and see if it is within the tolerance limit. These cones also will come with a calibration certificate, probably every year or two before the start of very important projects. You need to calibrate the inaccuracy less than 0.125 MPa in terms of tip resistance. As per the ASTM standards, it should be less than 1 to 2% of the full scale output. So you can follow that guidelines. And this certificate has to be produced before you start the test to ensure that the data that you acquire from cone penetration test is reliable. Right? And during the course of the test, it's also important to de-air the cone to get a good pore pressure response. And the following components of piezo cone should be entirely saturated. That is the pore pressure filter, the cavity between the pore pressure filter and the pore pressure sensor, and housing of the pore pressure sensor. So you can create a vacuum pressure here, and then you de-air the cones. And why is this de-air and saturation necessary? So it is necessary to get good resolution of the data. As you could see from right to left, the saturation is getting poorer and poorer. This is the good saturations, it is getting poorer and poorer. And you see the resolution of the data is getting diminished as the saturations becomes poorer. And if it further deteriorates, you will not get any pore pressure response. And without pore pressure response and further interpretation of data becomes useless. So you have to rely only on the cone resistance itself. Okay. Now I draw your attention to another very important aspects on the geometry of the cone. As you could see here, the pore pressure is measured at the U2 location, that is called at the shoulder or the behind the tip. And there's also a net area here. So this is the total area and this is the net area. So we define area ratio as your net area divided by the total area. That defines the geometry of the cones. There are many cones with varying geometry. Ratio to 0.38, as low as 0.38. So what happens if you have a 0.8? There's a 1 minus alpha is the correction that you need to apply to that measured quantities. But if the area ratio is very small, this 1 minus alpha becomes a large component of the corrections than the measurement itself. So we tend not to use area ratios very low values, but normal practice is to have a area ratio of about 0.75 to 0.8 is a good practice. But although there are many manufacturers use the cone with a very low area ratios, and because of the obvious reasons, we intend not to use with a low area ratio. Now, with different area ratios, different cones will give you different resistances, as you could see on the left screens, but it is very difficult to use them for the further assessment and interpretation. Therefore, it has to be normalized. So you have to correct those things. You could see the corrected cone resistance collapses to one value. That is by QT is the corrected cone tip resistance. How do we do that? So the corrected cone resistance QT is your raw cone resistance QC plus U2 is your pore pressures into 1 minus alpha is the geometry of the cone area ratio. And excess pore pressure I already explained is U2 minus U0, which is nothing but your delta U. And friction ratio, RF. I will also talk about the normalized friction ratio in the next few slides. Don't get confused. This friction ratio here is your sleeve friction divided by your cone resistance. And the pore pressure ratio, BQ, is your delta U divided by your corrected cone resistance minus your overburden pressures. We call this as net cone resistance QN or QNet. Okay. Now this is a CPT equipments. You can have many versions of it. All that you need is a thrust to push the cone into the ground. Okay, it can be a skid mounted, trolley mounted, truck mounted. The right side one you see is an offshore version. So instead of the sampler, we introduce this CPT cone using an umbilical that goes into the boreholes. There will be a nice bottom hole assembly. There will be landing ring, the latching units. When it gets latched, then hydraulical thrust will push the cone, and thus you get the data. Then you pick up the entire tool out and then push this cone back, and it is ready for the next test. Okay. Now you can push the cone from the ground until the penetration that it can reach. There are various termination criteria. Either it exceeds the limit of the cone resistance or the sleeve friction or the pore pressure, or if it exceeds a certain inclination of the cone itself, or is the operator's discretion in terms of not jeopardizing the safety of the equipment, the termination of the cone will be made. So as you push the cone from the ground, you could see in real time the cone resistance. The blue line is your cone resistance. Okay, this is terminated at around 18.5 meters, and the sleeve friction is your red one, right? And this green is your pore pressure. Okay, the thick green one is your friction ratio. So that is an interpreted value. That is your sleeve friction by the cone resistance. But the raw measurements is your cone resistance, tip resistance, cone resistance, and the sleeve friction and the pore pressure. So this has also been interpreted and correlated with the boreholes on the right side column. As you could see, this is one layer here. It already make out the layer change. Okay, there's a stiff material, very soft place from 0 to about 8 meters. There's a stiff material. There's a very soft material here, and then further there's a competent material. And these layers have been captured by the borehole data itself. Therefore, it gives very high confidence to use the CPT data as it is been correlated very well with the borehole data. So this we call it as seabed mode or the ground mode. So the data you get is about 18 meters, but if you want to design a pile which is going to about 50 to 60 meters or 100 meters, you don't get the data below 18 meters. So you have to drill the borehole, wash that material, and then you start pushing the cone beyond that depth. So we call it as the drilling mode or the downhole mode. So in the drilling mode or the downhole mode, you wash the borehole, push the cone. So normal practice is to push it at every 3 meters. Okay, then you wash the borehole again, you push another 3 meters, wash the borehole another 3 meters. So every increment or interval you're pushing the cone from the bottom of the borehole, there is a hydrostatic head acting on the top of the cone. So this has to be corrected to ensure that the data will be as good as you are pushing from the seabed until the desired penetration. So as you push the cones for every increment, you actuate the hydraulic thrust and you can see the data in real time. Now how to correct this CPTU, which is zeroed at the bottom of the borehole for every increment, that is in the drilling downhole mode. So this is the raw data U2 star you get from the bottom of the boreholes. You add this hydrostatic pressure, gamma W is unit weight of water into depth. You get your U2 value, that is your pore pressure. And QC will be your QC star that you measure from the bottom of the boreholes and add your hydrostatic head with a cone area. And the corrected cone will be same as we described in the previous slide. QC, which is nothing but this, plus 1 minus alpha is the area ratio of the cone, and U2. U2 is nothing but this because you already corrected. And delta U is U2, which is nothing but this, minus your U0. U0 is a hydrostatic head, gamma W into depth of the borehole plus water depth, right? So then you get this QC, U2, and QT. Then further you can use the same data for further interpretation. So with this, there's also quantities I draw your attention for the normalized values. Normalized cone resistance is defined as the capital QT is the corrected cone resistance minus your overburden pressure divided by the effective overburden pressure. Normalized friction ratio, that's why don't get confused. The previous slide you saw that was RF. This is FR. Okay. So the RF there is your sleeve friction by the cone resistance. Here, this is the sleeve friction divided by the corrected net cone resistance, that is corrected minus your overburden pressure, and the BQ. So these quantities is prescribed by Roth 1984 and 88. Okay, these are very important parameters. And further, this interpretation chart, which is still a gold standard, although there are many other charts are also in practice. The y-axis is your normalized cone resistance, capital QT. This is normalized friction ratio. It is this one, capital FR. Okay. And the right side's one is your pore pressure ratio, BQ, on the x-axis, and the y-axis is still the normalized cone resistance, capital QT. So based on those measurements, if the data points falls in this zone 3, it can be interpreted as clay. Okay, the higher the number, more coarse is the material. Suppose it falls in 5 or 6, it becomes silt and sands. So the 5 is sand and 6 is sand, clean sand, silty sand, so on and so forth. So generally, if it is cohesive soils, it will be in zone 3. So either you can use the friction parameters and the cone resistance to get this data, or you can use the pore pressure ratio if the pore pressure sensors are functioning properly and the vertical corrected cone tip resistance, right? So we have used this chart and developed our own spreadsheets to see the data will be used for interpretation. Zone 3 in green color shows the cohesive soils, and the other one is BQ versus your normalized cone resistance, right? Now this is 0 to around 35 meters. Essentially, you could see the green color one falls in zone 3. It says it is cohesive material, except this material is a stiff crust. Okay, and this cone resistance can be used very accurately for the stratification purpose, as you can see here, using this cone tip resistance and friction ratio and the BQ parameters. This is nothing but the soil behavior type number is exactly the same number what you saw in the previous slides. And zone 3, I recall here, it is cohesive material if it is clay, right? So we'll just make some illustrations with CPT. This is one of the raw data. As you can examine the data, you can break the stratifications here. So I think probably you can break the stratification here. One layer, second layer, there is a competent sand layer up to this level, up to 12 meters, and then probably up to this level, this is a cohesive material, and finally you have the sand. So you have 5 layers. If you do a bump over boreholes, the borehole also captures these 5 layers, so which correlates very well with the CPT data. So that gives us more confidence to use the CPT data. Okay, all the 5 layers. Now you could see here 3 meters, you see some spikes on the cone resistance. It indicates the sand layers. So how do you indicate whether it's clay or sand? In cohesive material, the tip resistance will be very small and the pore pressures will be positive. Okay. In case of sand layer, the tip resistance will be very high and the pore pressures can be either 0 or it can be negative here, because it's a free draining material, the sand, and the clay is plastic in nature, and it will generate pore pressures when you push the cone. So here the peak you could see probably is due to the sand lenses, and that will also decrease your pore pressures that you can see here. The same thing at 9 meters, you have the sand lens or the sand, small thin layer of sand, and you could see there's a drop in the pore pressure measurements, right? And so with this between 17 to 19 meters, also the same. And as you could see here, between 10 to 15 meters, this is cohesive layer because your cone resistance is very small and you see a positive pore pressure. Okay, if you draw a hydrostatic line, it will go follow somewhere this line, that is your gamma W into Z. So further with this, I will try to illustrate a couple of quick case studies on the foundations. This is a mud mat. We already know that this is a temporary seafloor support, and the bearing capacity has to be estimated, settlements to be computed, sliding, overturning checks has to be made. So you need a thorough site investigations. When the investigations becomes a part of the pile foundation designs, then very little attention is given to characterize the top 3-4 meters of the ground, because it's very least important for the design of foundations. As you could see, the CPT data here essentially is cohesive soils with 2 silt or sand inclusions at various depths, but the design parameters developed is around 2 to 18 kilopascals between 0 to 3.9 meters. Yeah. Okay. If you examine this 2 to 18 and you see the measured data based on several measurements, the tar vein, mini vein, and others is only around 4 kilopascal. Okay, so this over predicts your bearing capacity. If you consider this to be more appropriate, even now, if you consider this, this becomes a layered profile. There is a very weak layer or a strong layer, so you need to consider some kind of modified bearing capacity factors to evaluate the bearing capacity. If you don't consider those modified bearing capacity factors, there are many methods available. So you can end up having a 10 meters wide foundation can give you an ultimate resistance of about 10 meganewtons. But if you do a modified bearing capacity approach, because the weak over strong layer and considering the influence of that, you will get for the same size about 1/4 the capacity. So in one of the cases, we actually verified this numerically and analytically. It's having very close agreement. Okay. Now, one more important aspect is there could be some mounts on the seabed. It never be going to be a flat surface. Okay. When you see the mount like this, one corner of the mount, the the mud mat can rest, the other three legs can lean. That is a hazard that has to be evaluated. And you could see the hazard. One of the jackets which was just appended, unhooked from the crane, and then it capsized. So $40 million is gone into the ocean. So either the ground was not characterized properly in estimating the accurate design parameters. Maybe the surface was not level. So regardless, there's a geohazard, so it has capsized. So the another case study you could see here is a tripod jacket, which has the corner skirt piles. Okay. The skirt piles are driven through the skirt cans. This is not a main pile which normally will go through this jacket can, but this is a skirt pile, so where the piles are driven underwater and the skirts are welded to the jacket. Okay. So in this case, the contractor, while installing the jacket, took about 2 days more time than he planned in his project plan, because he has to do the leveling of the jacket, and he claimed and allegated that the owners did not provide him the accurate geotechnical data. So because of the inaccuracy in the data, he has to spend 2 more additional days, and he wanted to claim for that. Then the owner said, okay, you can get a certificate based on the available data from Dr. Partha. If he certifies, then we will consider your extra claim for this. But I was the quality control supervising this job on behalf of the end client or the principal clients during the geotechnical investigation stage. And also this contractor was my client during the construction stage where we monitored those piles. When the contractor approached us, then I could not say that the data was inaccurate because I personally supervised the data. Okay, so what we normally do in the offshore geotechnical investigations, establish the seabed. That is the first part we follow. That's very important. So you see these bottom sensors, which is lower down into the drill pipe. The drill pipe with the bit at the bottom is just off the seabed about 1 or 2 meters. Okay, when it come and nicely rest on the landing ring, the entire drill pipe is lower down. Okay, and now this touches the seabed. So you have a switch here. When it touches the seabed, there's a circuit getting closed, and you put a bulb here, the bulb will glow. Okay, that's how you, when the bulb glows there, you mark 0 on the pipe. When mark 0 on the pipes, that's a reference point where you're touching the seabed, and immediately you collect the samples. And once you collect the samples, you measure with your torvine, you could see here, and get the under shear strength. Okay, and even in soft clays, very soft clays, you use a polycarbonate material. We call it as liner sampler. Okay, which will hold the samples, otherwise it will going to slip. And then further thereafter, you wash the boreholes and continue sampling until the desired penetrations are reached, and concurrently the laboratory test will be performed for each meter of the sample that is collected in testing for under shear strength. And thus we complete the boreholes. So with this much of accuracy and supervision has been made, so we cannot tell that the data was inaccurate. So what was wrong in this location? So we closely examined the geophysical data. When we closely examine the geophysical data, these are the water depths. You see 81.9, 82 meters. But this circled area is having a trough compared to the rest of the other locations. It is 81.4, 81.5. So about half a meter to maybe nearly close to a meter. Okay. And you see the multi-beam bathymetry also suggests that the blue line and the green line as a different elevation. So one part of the mat is in a trough. When you zoom the bathymetry data, you could also see that possibly one of the corner of the mat was resting on this, and thus it has not been leveled at the first place. They have to spend a lot of time because suction is created during the installation, and they have to do. So these simple things, the physical data was not assessed together with the geotechnical data in designing the mud mats, and thus they have to spend extra manpower. So we straight away rejected that. There is no issue in the geotechnical data that is furnished by the client, but it was the contractor and the design team was not considering the geohazard by evaluating the geophysical data, and thus they had to face some serious problems. So the last one on the offshore side, you see the piles going up to say 670 to 100 meters below the seabed. Okay. Now, if you look at your ground model that is given in the geotechnical investigation reports, you see the limiting friction of about 20 kilopascals. This normally for sand, limiting it to 20 kilopascals implies these are all carbonate material, carbonate sands, which has a very low friction. Okay, and accordingly, based on the ground model, the pile capacities will be assessed. You see, assuming that friction of 20 kilopascal of limiting frictions, you see a very low resistance at the top. Okay. Even the drawings also prescribe that the pile should not be dropped, but should be gently lowered and complete the rundown. So everybody was expecting the pile will run down because the ground model suggests that 20 kilopascal unit skin friction for designing the pile is fine because it considers the carbonate content into picture, right? The pile retainer should be designed and provided for P1 and P2 segments because they are afraid that the pile will run down, so they need to put the stoppers. Drivability was carried out for the pre-installation hammer selections, developing the soil resistance to driving. So they predict that there will be some sulfate penetrations of about 16 to 24 meters. Right, and the wave equation programs, the output giving you the blow counts versus penetrations also predicts a sulfate penetrations because the input you are giving is your 20 kilopascal limiting skin friction. So accordingly, the soil resistance to driving is developed, and thus the blow count will also give you these sulfate penetrations of 16 to 24 meters. But actually, when they started installing the pile, it hardly penetrated, and you could see they have to drive with a hammer with a very low energy to surpass that layer. But the geotechnical data doesn't capture that, the ground models, and the same ground model is carried until the end of the designs. So what could be the reason? So when we went back, you could see there are hardly 1 meters of penetrations as against the predicted penetrations of about 16 to 24 meters. But if you examine the CPT data, you see the top 6 to 8 meters is having refusal depths around 20 to 30 MPa. So this implies that this is a very cemented sand. And if you elaborate this, zoom it, and you could see for various penetrations in the top 12 meters, there's a 20 MPa of penetrations is minimum achieved. So you cannot ensure that the pile will penetrate this cemented layer. But because this was carbonate in nature, the geotechnical ground model that is in the geotechnical report assumed a 20 kilopascal of limiting skin friction, and thus people ignored the cemented layer. So the designers are always based on the geotechnical investigation report, but they also need to consult an expert to look into the detailed aspects. So these are simple hazards and simple things, but it created a lot of problems, site issues, because the piles do not penetrate, the stick up length is very high, then they cannot place a big hammer to drive the pile because the hook length was not possible. So they have to put a small hammer and then you have to drive the pile and later on hook up the big hammers. And so this causes unnecessary delay and of course the cost. Okay. So with this, I come to completion of these offshore site investigations. Let me give you some very basic illustration of the onshore site investigation. The next about 20 minutes, and then we can take some questions. So as you all know that the stratigraphy varies across geographies. The red ones marked are all residual deposits Then the gray one is black cotton soil, is a very problematic soil. The coastal areas in the west coast and also the east coast, like your Kakinada, Vizag, Paradeep. On the right side, you see very, very soft clays. As you go to the north, you see deep-seated alluvial deposit silt. We don't have rock even up to about 100 meters or 150. This complex and wide distribution of the stratigraphy is imperative that one need to do a thorough geotechnical investigations, because the behavior of this ground under loadings will be different in different geographies. The first and foremost method of investigations is to open a trial pit where you get a physical feel of the sample. You can collect some undisturbed samples, you can collect some block samples, normally about 2-3 meters depth. So useful in small structures, maybe for pavements and so on and so forth. If you want a little more deeper depth of investigations, you can go with a mechanized auger, which is still not popular in our country, but we have the casual labor still rotating the auger by manual methods. Okay, you can rotate, you can remove it, clean. You can collect undisturbed samples in this borehole or conduct an SPT. So SPT is very widely used. Okay, I'll talk about this in the next few slides. And then you measure the N values. So as you open this split spoon sampler, this itself will give an indications of the materials. So when the sampler is split into two halves, it indicates it's more silty or coarse materials. When it doesn't, then it is cohesive material. So I have a lot of experience in evaluating this. And you see these more silty fine materials. And this will also give you a very good indication that these are all virgin soils, and all those washed materials or the debris is cleaned at the top. That's why you see give a seating blows to ensure that the further penetrations will be in this virgin ground. Therefore, you are measuring an accurate N value. So in the boreholes, you can also collect undisturbed samples. It's very important that we need to give importance to the area ratio in order to get good quality samples, which is defined as the OD square minus ID square by ID square. Okay, the area ratio should be less than 10% is the requirement. The thicker the wall, the greater the disturbance. So the standard penetration test sampler, the split spoon sampler, if you work out for its geometry, the dimensions, the outer diameter of 50 millimeters square and the inner diameter of 35 millimeters square, you get an area ratio of more than 100. So thus your samples from the SPT is badly disturbed. So you cannot use that for any engineering property test, although we all of us know that these samples from that SPT will be straight away used to perform an unconfined compressive strength, which perhaps will over predict your undrained shear strength. Okay. So you collect the undisturbed samples, you wax it to retain the moisture, but these are all non-standard with variable area ratios, maybe around 20% to 30%, or and the sizes also will vary, depends on the contractors. Our normal practice we do in the offshore site investigation is to use a seamless Shelby tubes, stainless steel, and these are all not seamless, these are all welded joints that also affects the sampler. With the seamless Shelby tubes, you get a very good recovery and high quality samples. Okay, almost we have seen about 100% recovery of the samples. Okay. You can collect the undisturbed samples and complete the SPT for a shallow boreholes. You can do a continuous SPT, collect some undisturbed samples, and record these N values. Okay. General practice is to do at every 1.5 meters, but if you are using a manual auger in the top 5 to 6 meters, we prefer to have at every 1 meter so that you have more number of N values that you can average it out. But this was for a failure forensic study, so we wanted to have a continuous values, and you have a sample here which we tested in the laboratory to arrive at the cause of the failure. Now, if you want explore depth of investigations beyond that manual auger capability about 6 meters, then you go with the mechanized methods. So this is a primitive calyx type. Is not actually a calyx type, is a calyx type of drilling rig, okay, which has some limitations, which doesn't rotate under an axis, it will wobbles, okay, and that will give you a very bad quality of core samples. We'll examine that. The other one is the hydraulic machines, which rotate at an axis, which doesn't wobble here. So the quality of core samples collected from the hydraulic machines will be of very high standards. But both of them are rotary methods. That means for every increment interval, you need to bring up the core barrels and insert an SPT rod to conduct the SPT, pull out the SPT rod, and then you have to insert the core barrel again and continue for further depth of investigation. Or if you're drilling it through rocks, it's the same method. So the time it takes to complete maybe about 20-30 meter boreholes, maybe around 2 days, 3 days, sometimes it will be more. In both of the methods, both calyx and hydraulic rigs, you circulate the drill fluids which come from the center of the rod, then the cuttings will be displaced to the annular space, okay, and then it will be recirculated. Okay. So it's very important to use the drill fluids. Without the drill fluids, then you get wash samples, because these drill fluids will hold the particles in suspensions before you pull out the core barrel and insert your sampler to do the SPT or undisturbed samples. Without the drill fluids, then these heavy sediments will settle faster, okay, and thus you recover contaminated samples, not the undisturbed samples. And I could see here, this is, again, all the fines get washed. If you don't use appropriate drill fluid with an appropriate consistency, then you get the wash samples. These are not representatives and adds no value. Even in cohesive materials, if the boreholes are not washed properly, the stiff materials will be characterized as soft materials, and thus you are under predicting the capacities. Okay. Now, I'll just give you some illustrations on the SPT. The history of SPT you are seeing here. Most important thing is that at 1947, Tazagi christened the Raymond sampler as the standard penetration test. The first publication on the correlations was released in 48, and later on the ASTM adopted in 1958, right? Several countries has their own codes, and so within India has IS 2131 1963, which was reaffirmed in 2002. As you look at the last columns, most of the countries follow the ASTM standards for performing the SPT. So why do we perform SPT test? To do a static soil property evaluations, getting relative densities, friction angle, and end shear strength, perform a static analysis, bearing capacity settlement, even deep foundations, get the capacities, and dynamic soil property, and most importantly for the liquefaction potential assessment. So I think all of us are familiar with this. So the different hammers that can be used for conducting the SPT, the safety hammers, the automatic, and the donut hammers. The operators, you could see they can be experienced, non-experienced, or negligent, and the drill is different, drill methods are different, okay. And this is very popular. The donut method is popular. The other ones are not very popular in the country. The various SPT methods to drive, are these SPTs going to measure the energies? We are not sure. Without the energy measurements, it is not standardized. So as you recall, the National Bureau of Standards in US released in 1981, they released that energy ratio is between 40 to 90%. With this wide energy ratio, which was calibrated to about 13 rates, gave very little confidence on the energy transfer, and thus it requires to standardize the SPT N value. So the non-standard SPT systems delivers highly variable values to the drive rods, and it does affects the N value. The soil strength estimated from N value is based on experience, that is the average N. So to obtain the normalized value, that is also necessary for reliable static analysis and the liquefaction potential. So I'm not going to much details. I think all of you are familiar with this. The normalized value for the energy transfer based on the borehole diameter, sampler, and rods. You have various correction factors, the overburden pressure. The IS codes also capture this. Okay, but I draw your attention for some experience in different geographies. The Greece experience on various locations, they get with the manual systems, you get about 46% with an auto system of 77% of energy transfer. 86% of energy transfer is the Saudi experience. With this 86%, when the required capacity is around 200 kilopascal, with the accurate measurement of energy, you compute a bearing capacity of 250 kilopascals. Without the energy measurement, you assume that the 60% energy transfer, you compute 150 kilopascal, but the requirement is in between. So you end up having some remedial measures, and also this will be expensive. You need to spend a lot of money, right? So Batilas 2016 has summarized the energy transfers varies between 1% to almost about 90%. And this is very important to liquefaction assessment, where you have this chart which delineates the zone of soils potential for liquefactions and potential for non-liquefaction. If the energy measurements are not made, you can qualify a soil to be non-liquefiable, although with the energy corrections it can be qualified to be liquefiable or vice versa, right? And this is very important to measure the SPT. So this can be done by an instrumented rod mounted with two reusable accelerometers and embedded strain gauge below the anvil, and measure the energy. So we started calibrating all the rigs that is operating for the last few months. So my engineer, Mr. Ramchandra, has taken a lot of efforts to do that. So in one of the projects, you could see this N value of 39. The average energy transfer is about 90 kilojoules, where your right. So this 39, if you do a field correction for the energy transfer of over 20%, you get an N value of only about 12. And further apply the overburden as normal, you end up having a corrected N value of over 20. If you use this 39 without the energy correction, straight away apply the overburden corrections, you compute that N value to be 62. So it's almost 3 times you're over predicting the capacity. Right? So this is a flow chart. The field corrections as a part of ASTM 46336066. Our Indian standard doesn't talk about this energy. In fact, we informed the Bureau of Indian Standard. They have told that they're going to introduce in the subsequent revision as an optional item, and perhaps when people start using it in the next revision, they're going to make it mandatory. Even in US in 1981, they released that. It took about a decade to actually bring it into the practice. Okay, and different rigs have been calibrated, and you see these various methods, and the pulley is a wire rope. So this will all affect your energy transfer. Okay. Now we also accumulated a lot of database as we calibrated the rigs, and you could see here it varies between 25% to almost about 60%. Only one of them. Otherwise, it is between 30 to 45%. So with this hydraulic, I make one illustration at various depths. 1.5, the energy transfer is so on and so forth. So take an average energy about 42% and 46%. So if you make that correction here, the field corrections, 48 becomes 33, 18 becomes 12, and so on and so forth. And then applied further the overburden pressure, it becomes N160, the corrected values. Okay. So this is very important that you need to measure the energy and then apply those field corrections, and then further use those values for further processing of this. And this is another one, the other hydraulic rig, Joy 12B and 12C, which measures only 34 and 40%. Okay. This is a US practice. So this has been a common practice in US. We use this bore lock to do some foundation designs. You see these N field measurements. Actually, they also plot in the bore lock itself the field corrections, because these are automatic hammers which measures very high energy of 85–90%. That's why you see an increase in the N values while applying the field corrections. Okay. So once you done with the SPT in the overburden, then you enter the rod. So I'll last aspect, and then I can stop because we are overrunning the time. The single tube core barrel, if you run here, the drill fluids will be in direct contact with the soil, correct? Right. But if you use a double tube core barrels, the drill fluids are diverted to the annular space outside, and then the cuttings will be brought out where it will not be in the contact with the core samples. And more so, if you have another tube inside, we call it as the triple tube core barrels, that will have a very high recovery. Okay. This is a triple tube core barrels. You have the third liner piece inside. And the core samples you get even in this weathered rock is of high quality. This is like a sand. No, it is glued together. But if you use a single tube core barrel with a calyx machines, you will never get these samples because these materials get washed away as the drill fluids are in direct contact with this material, right? So core recovery and RQD, I think I can skip this because everybody is aware, but I want to give you very important aspects of using this RQD in evaluating the rock mass quality, right? So let us examine the core samples. Before that, it is also important to use appropriate type of drill bits. You can have a surface set bit or an impregnated bit. This impregnated bit will have several layers of diamond studs. This one is only one layer of diamond stud. Okay, if this is worn out, you have to throw this. But if the one layer is worn out, then there is a fresh diamond that is appearing again. So the productions is very good. So this is a reamer shell and a core catcher. This is a diamond bit. Okay, so there are different grades of diamond bit to be used. Synthetic diamonds, which has 10 to 12 stones per carat, okay, which can operate in a Morse hardness of about 1 to 2. When you have very hard materials, you need to have grade of diamond 60 to 80, that is 60 to 80 stones per carat. That can be for basalt, dorite, much higher, or very strong rocks. So appropriate diamond cutting tools has to be used for different materials to get good recovery and so on. So this is a shale sample. As you could see here, triple tube core barrels give you very high core recovery. Okay, and these are the joints. Okay, as you can see here, and this has to be identified by your logging. There are different joints and the joint sets. So these three are one set and this is the other set. Okay, but what you could see here is the mechanical breaks. So these mechanical breaks, if you consider and then evaluate the length of these pieces, then it will diminish your RQD. Okay, so you can always join these things to improve the RQD, which I learned by an experienced geologist to do that. But you also need to have some experience in looking at the core samples, whether it's a mechanical break or it is actually a fracture or a joint. So these are the joints, as you could see here, right? So here is a joint. Okay, this is another joint. This is another set of joints, right? But you see here the mechanical breaks. These can be joined together because many of these pieces are less than 10 centimeters will always diminish your RQD. What is the implication of that? So when you're evaluating the rock mass rating, you have this following set of parameters, right? So strength of intact rock, you have certain ratings. RQD, you have certain ratings. Spacing discontinuity based on your joints and joint sets, you have certain ratings. Condition of discontinuity and the groundwater conditions as the ratings. So this is in IS code 12070 and 13365. So I can skip this. All that I want to draw your attention is to qualify the rock to be very poor to very good. But if you look at this rock mass, rock core samples, looking at this, all of them are less than 10 centimeters. So you have very poor RQD. So 26% in this row. There's some bigger pieces here. You get 51 and 50. But closely examining these rock core samples, the joints are very little there, but all these breaks or mechanical breaks are due to drilling disturbance when perhaps the right tooling was not used, right machines were not used. In that case, you end up having the rock qualified as fair rock or fair to good rock and fair rock. But if you improve that by considering those mechanical fractures as an intact pieces and join together and improve the RQD, in the next slide, I will show you that you can improve the RQD by joining some of those pieces like this, okay, in these pieces. So it becomes 66, 73, and 80, and the fair rock can be qualified to be a good rock. Another illustration. So looking at this piece, RQD is 0, yeah, because none of them are more than 10 centimeters. But these rock core samples do not have actually joints or fractures. These are all mechanical disturbance. So you can actually improve the RQD. So what happens if it's 0? It becomes poor rock or very poor. But if you can improve those RQDs there, you can qualify that to be good rock. So what is the implication? Bearing capacities can be higher. properly your appropriate tools for your socketing, your other construction guidelines. So these are simple things, but I thought that is very important to share with you. And we have done this in many projects. I personally have learned this from a very experienced geologist who used to be a general manager at the Karnataka Power Corporation. We went to sites on many occasions, and then he taught me how to do that. And then we bring in that kind of experience. And I request all the youngsters, no, you need to have a hands-on experience on the ground so that you can get a feel for it, and thus you can provide a very good quality of data. The last one is for an iconic bridge. Also, you see those are all the drilling disturbances. If you improve the RQD from 54% to 73%, you can qualify this to fair to good rock, right? So the last slide, I can stop here. This is a very sophisticated multi-purpose drilling rig, CSR 174 from US, which can conduct an SPT test, CPT test. It's a wireline or a rotary core drilling rig. You require this kind of very good rig, which has high power and automatic SPT hammers, so that you can get high quality data. So we actually planning to commission this by this Dasara in the next couple of months, and we wanted to bring this from the US. So I think I have run out of time, although I have some couple of case studies. Maybe I can stop here and then I can take some questions. So thank you very much, sir, for your patient hearing.
Thank you, sir. Thank you so much. It was very insightful session. You have given us a vast understanding of various geotechnical investigation aspects, both onshore and offshore. Thank you so much, sir. There are a few queries from the participants' end. And the first query is from Engineer Mohammad Titumir Hassan. And the question goes like this. Can we prepare soil report based on only SPT or CPT for foundation design?
There is also a common practice to prepare based only on SPT or CPT. For example, CPT. Not do it on a new area where you don't have a correlations between the sample tested values and the CPT. You need to develop the correlations between the sample boreholes and the CPT. When you have built that confidence of correlations and subsequent locations, yes, you can do that, and it has been a practice. So for the new locations, I cannot use the CPT data because I don't know what should be the parameters. For example, in developing an undrained shear strength, you have a non-dimensional parameter called NK, right? So this NK factor depends on your established correlations between the sample. It can vary between 8 to 25, as we have seen in different geographies. So for that geography where you intend to use that, you need to develop the correlations. If you have that confidence, straight away you can use. SPT, yes, you can get samples, you know what type of material it is. As I said, now this is very subjective. So therefore, always we prefer to have some undisturbed samples and then do the testings. But in our large scale infrastructure projects, is very unlikely that the undisturbed samples will be collected, tested, because nobody gives time and nobody want to pay that also. So it's also 99% people rely on SPT in our country. And that's where, at least when we are relying on the SPT, so let us do it properly. Things. No, you see how much confidence you get when you calibrate your rigs and get your energy transferred to the rods, and thus use that field corrections. Therefore, your estimation or other computations of engineering parameters will be of very high confidence.
Thank you, sir. The next query is from Krishnan Srinivasan. What is the depth of foundation we require for the water villas and the lagoons? Do we have to do the soil test?
For every building, you need to do a soil test. I have shown and I have experienced the distress to a very small structure, lightly loaded residential building. We have seen distress to high-rise buildings. So regardless of the type of structure, the geotechnical investigations are necessary. Of course, you can adopt different methods. As I explained, trial pits, you can open, you can do some small boreholes, auger boreholes. You don't need machines to go and drill deeper if you need a depth of investigations of hardly about few meters. But also local experience you can derive, and soil testing is necessary for all the projects.
Thank you, sir. The next is from the participants seeking your suggestion for young future geotechnical engineers.
Okay, maybe I will do a session on the opportunities in geotechnical engineering itself. So I'll share my personal experience and also future where and all the opportunities are there in geotechnical engineering. So just to give you a very brief in next 30 seconds, so I can do a session on that itself. So people can opt to be a designer, people can opt to be a field person, people can opt to be a laboratory engineer, and people can opt to be a project management consultants. So all these options exist even for geotechnical engineering. But I would rather sincerely advise all the engineers, young engineers, to pursue only if you have passion. And the first few years, I also insist that the site because they need to understand the first-hand information. Unless they had the first-hand information, they'll not be able to better interpret the results. There are many things that goes into the site investigations. You know, the drilling tools, the drilling methods, drilling rigs, the operators' inconsistencies. When you have a hands-on feel, then probably you become a designer after a few years. You can better interpret the results. So there are multiple opportunities for geotechnical engineer. As we speak, there is a huge investment is going to be made in the country, and we have lack of skilled people, and therefore the potential for the engineers are there. In fact, we are also discussing along with the Deep Foundation Institute to conduct some training modules for the field engineers, field supervisors, lab technicians, and so on and so forth. I hope very soon we will be successful getting the government's nod so that all the young engineers can be prepared to be future geotechnical leaders.
Thank you, sir. Thank you so much for your suggestions. There are a few more queries from the participants, and this query is from Avik Kumar Mandal. The question is like this: which type of pile integrity test is preferable for checking the integrity of the long pile, say the pile length or diameter ratio greater than 20 or so? Please discuss on this.
Okay, I think this is beyond this topic, but still I will say a few words. Pile integrity test is a very simple, but how much money the client want to spend? Do you have many methods available? You can use a PIT when you have L by D ratio, even up to 30, 40, 50, we have tested and it was successful when you have a soft place. But there are other methods normally practiced is this cross-hole sonic logging, which requires preparation of the piles by inserting the access tubes, and then post concreting you can introduce your trans receivers into those probes and test for it, and within the cage this cross-hole sonic logging test will give you very accurate estimation of the integrity of the pile. But there are other very recent advancement also called the thermal integrity profiler for very large diameter piles, and depth is no constraint in that, where the thermal sensors or thermal wires are embedded along with the cage, and then you place the concrete into the pile, and within 24 hours it measures the temperature during hydration of the concrete. You can evaluate the integrity of the piles, whether the shaft is homogeneous or not. So for large diameter pile, it is very, very popular. In US, I think 100% of the piles are tested with integrity measure, but there is a requirement of the cost involved there, because you need to use a sacrificial thermal sensors. So these are very expensive. It's not available in the country today. I don't think anybody have used yet in this country, but very soon I also want to introduce, being the technical partner of Pile Dynamics. We have the cross-hole sonic logging test that is already been used on many projects.
Thank you, sir. Mr. Avik has one more query actually. Is it preferable to conduct both the static and dynamic pile load tests in the same pile, or the load tests are to be conducted two different piles in near vicinity to each other?
Two similar piles is always preferable, although some of the correlations they have done on the same pile. They do a static load test which doesn't have any impact loading, and thus they conduct the subsequently the dynamic load test. But I would rather suggest that you can have two separate piles. That will be very good. But and the same pile also has been done. But if you are doing a dynamic test, but you need to consider the time, because dynamic test will remold the soils due to an impact. So you need to wait for some more time, maybe about a month or so, before you conduct the static load test if it is on the same pile.
Thank you, sir. Mr. Krishnan has replied back to your query that you have answered regarding the soil test for the deep foundations. He says in Maldives, for water villas in lagoons, soil test is not being carried out since the depth of foundation goes only 1 meter below the seabed. Sir.
Yeah, I showed the picture on the distress. These foundations was hardly a meter in Bangalore. I can quote about 50 projects in Bangalore which I have done the remedial measures to arrest those settlements. Okay, if the soil is so good, probably they may not require, maybe Maldives, I don't know the stratigraphy there. If it is a good stratum, it may not have any problem. But still, I think the statutory complaints also you require soil test, because the plan sanctions and others, even in our country, in our BBMP, also insist that you need to get the soil test reports before the getting the plan sanctions. I'm sure even that country will have the statutory requirement of getting the soil test done.
Right, sir. Thank you, sir. This query is from Mahadeva CK. How to find the SPC of the soil from unconfined compression test?
Okay, if it is cohesive soil, straight away your safe, because you know the ultimate capacity is your 5.14 times your undrained shear strength. So if you apply a factor of safety of say 2.5, then it is 2 times your undrained strength, and that is nothing but your unconfined compressive strength.
Thank you, sir. Thank you so much. The participants, for any queries, please forward us through your registered email IDs. So we'll get back with the answers also. Thank you so much, sir, for your information, sharing your valuable information. It was very knowledgeable. I now request Professor Manoj to propose the vote of thanks. Over to you, sir.
Good afternoon, one and all present here. As we have come to the end of today's webinar on case studies on geotechnical investigation, it's my privilege to propose the vote of thanks on this occasion. On behalf of our department, I acknowledge and convey my heartfelt thanks to the resource person, today's speaker, Dr. C.R. Parthasarathy, founder, chairman and managing director, Sarathy Geotech and Engineering Services Private Limited, Bengaluru, for sharing his knowledge and experiences on geotechnical investigations. Thank you, sir. I take this opportunity to express our sincere thanks to VVC management and our principal, Dr. B. Sadashivegowda, who always been the great support behind such events. Thank you, sir. It is a matter of immense pride for me to convey my gratitude to our head of the department, Dr. S.K. Prasad, for his continuous support and motivation in conducting such events. Thank you, sir. I would also like to render my gratitude to the program coordinators, Dr. P.K. Umesha and Dr. B.S. Shilpa Madam. Thank you, sir and madam. I would also like to render my thanks to moderators, Professor Arjun V and Professor Anjan B.K. for helping in broadcasting of this event. And I thank all my fellow colleagues, technical and non-technical staffs who helped in conduction of this event. Thank you. I would like to thank all the participants for their kind cooperation and see you all tomorrow morning at 11 a.m. for the next webinar on Enhancing Road Safety in India by Dr. P. Nanjun Swamy, Professor of Civil Engineering, SJCE, JSS Science and Technology, University, Mysuru. And the registration link is shared in YouTube chat box. Thank you all.
Thank you, Manoj, sir. On my behalf, I also thank Dr. Parthasarathy, sir, for sharing your information, knowledge in the field, and sparing your valuable time with us, sir. Thank you so much. I also thank all the participants for your enthusiastic participation. We hope such active participation for tomorrow's session also. Thank you so much, everyone. I, Madhushri, signing off as Master of Ceremony. Thank you, everyone. Stay safe.
Yeah, thank you. Thank you.
Thank you, sir.